Today we're going to be looking at 1.3, combining transformations. In the previous example in 1.1, we looked at shifts. And let us consider a really expanded form, like we start off with y is equal to f of x. And in 1.1, we expanded our understanding of transformation of functions. And so we dealt with the parameters for a shift, in which were h, which symbolized a shift to the left or to the right. And we also looked at k, which was a vertical shift up and down. And then we expanded our understanding and let us consider y is equal to f of x, our parent function, and 1.2. 1.2 looked a little bit different. Now, we could start off with y is equal to f of x, and then we expanded it so that we may consider y is equal to a, open brackets, f of b of x, and really a dealt with two different transformations. If a was positive, we didn't reflect about the x-axis. If a was negative, we reflected about the x-axis. If the absolute value of a was not 1, that we stretched vertically by a factor of a. Whereas b, now b was a little bit trickier. B was the horizontal stretch. And keep in mind that we're going to stretch by a factor of 1 over b. So if b was negative, we reflected about the y-axis. And if the absolute value of b was not 1, we stretched horizontally by a factor of 1 over b. So we can summarize all of these transformations in the general transformation model. Now, the general transformation model, I don't know if there's such a name that exists, but I definitely like to call it the general transformation model. And y is equal to a, open brackets, a times f, open brackets, b of x minus h, close brackets, plus k. Now, we could write a really crazy function with the parameters a, b, h, and k, and we're able to transform it. So we're going to wrap these all up, these shifts and the stretches and the reflections, and we're going to put them all into one go, the general transformation model. The reflections in the stretch and shrink have to do with parameters a and b. The shifts, and by the way, a and b, these are multiplicative. That is, you either multiply your x or y values by a constant a or b. Now, h and k were shifts. And if you look back to 1.1, these were additive. So when we're putting a whole bunch of transformations together, does it matter which order you apply the transformation? That is, if you have to shift 3 units over to the right and reflect upon the y-axis, does it matter that you reflect upon the y-axis and shift 3 units right? Yes, it does. Only one of those ways is correct. So how do you keep this straight in your mind? The orders of transformation is done with the orders of operations in mind. Let us go back to this equation up here. I'm going to highlight everything that we multiply in green. A is a multiplicative transformation. B is also a multiplicative transformation. And does it matter which comes before which? A, which is a vertical stretch or reflection about the x-axis, or B, the horizontal stretch or reflection upon the y-axis? It doesn't, because they're both multiplicative. H and K were both additive. Do you know what we do in math? We follow the order of operations. That is, we do the multiplicative first, and then we do the additive. Some people might even say, whoa, all of this is too hard. So if I just follow the order in which do they appear, will I get the right result? Yes, absolutely. So I'm going to read this part here. Since reflections and stretches are multiplicative, these transformations must be done first. Since shifts and translations are additive, these transformations are done next. Or, please do what your textbook suggests. Now, I've looked at this quite some time, and each time I look at it, I get confused. So, just come up with a way that you're going to apply the order of transformations. So, just look at the way that they appear. A appears first, B, H, and then K. It just so happens the multiplicative ones happen first, so why don't we just agree to apply them in that order? When we want to break the rules in advance, you and I can break the rules when we know a lot more about this. Remember, it's really important.